Rio is an intelligent I/O extension card that will turn the Raspberry Pi into an amazingly powerful and inexpensive embedded computer for robotics, autonomous navigation, machine control, industrial automation, home automation, automated test, or any other applications that need interfacing to the real world. Rio includes a DC to DC converter for powering the Raspberry and external sensors from a 10 to 40 volt external supply, a driver for 8 digital outputs up to 1 amp, 13 inputs that can be configured as 12-bit analog, digital on-off, or pulse capture, a high-quality 40-pin automotive-grade connector, an RS-232-485 transceiver, CAN bus transceiver, and a powerful 32-bit ARM Cortex processor. Optionally, the Rio can be fitted with a miniature AHRS module that includes 3-axis magnetometer, gyroscope, accelerometer, and inertial navigation software. Rio is shaped to stack nicely over the Raspberry using the 26-pin header. The communication between the Rio and the Raspberry is done via the SPI, and for some I/O types, the UART present on the 26-pin header. For this demonstration, we have 4 potentiometers connected to the Rio's analog inputs, a switch connected to a digital input, a ping ultrasound distance sensor connected to a pulse input, and 6 LEDs connected to digital outputs. The ping ultrasound sensor is a good example of the sort of I/O processing that can be done by the Rio's MCU. Here, the MCU generates the very special pulsing sequence needed by the sensor and directly produces a distance result in millimeters. Looking at the software on the Raspberry side, we have written a driver and a simple library for reading and writing I/O from a user program using very simple functions. Here is an example application program. We read the analog and ping inputs with a simple Rio read ANA inputs function. The value of the POTS and the sensor are then displayed with just a print function. The switch is sensed, and if it is off, the LEDs display a count pattern using the Rio write all digital outputs function. When the switch is pressed, a steady pattern is flashed. Let's now launch the program. We see on the console the values of the POTS, the ping sensor, and the switch. If we adjust the POTS, the values change on the screen. By moving an obstacle closer and further from the ping sensor, we see the distance value changing on the screen. The LED is displaying the count pattern. When pressing the switch, we now see the steady flashing pattern. Rio is at an advanced prototyping stage with all its core functionality proven to work. This demonstration shows that there are no technical obstacles to move to the next step, making Rio a reality. Thank you for your pledge.